In this lesson, you will learn about multiplying and dividing with scientific notation. Let's take a look at some notes and examples that better explain this concept. In these examples, we're going to evaluate each product. So we're going to go ahead and multiply these two numbers, which are written in scientific notation, and then we're going to write the answers in both scientific notation as well as standard form. So let's take a look at number 1. To simplify number 1, or multiply these two numbers, because they're not written as actual numbers in standard form, they're written in scientific notation, what we want to do is we take the 4 and the 5 and multiply those numbers together. And that would give us 20. Then what we do to combine the tens together, just like we've learned in previous lessons, because these bases are the same, we can add the exponents together. So we will add the 2 and the 3, giving us 5. So right now we have 20 times 10 to the 5th power. Now this is not correctly written in scientific notation. So to do that, we want to first rewrite this part correctly in scientific notation. So let's take a look at how we might do this. First, we want to write just 20 in scientific notation. So 20 in scientific notation would be 2.0 times 10 to the 1st power, because we're simply moving the decimal from the end of 20 to between the 2 and the 0. So we're only moving it one place. Now, we're going to take that and we're going to multiply it by 10 to the 5th power. And when we do that, we just simply keep the 2.0 part of the problem, and we're really just combining the bases or the tens together by adding the exponents 1 and 5. This would give us 10 to the 6th power. So in scientific notation, the answer is 2.0 times 10 to the 6th power. Now we need to write this in standard form. Now recall, when you're determining what the standard form or original number is, you're looking at this exponent first and seeing if it's positive or negative. If it's positive, you know the original number is greater than 1. If it's negative, you know the original number was between 0 and 1. So to create a number larger than 1, we want to move our decimal point 6 places to the right, because if we moved it to the left, our number would become between 0 and 1. So 1, 2, 3, 4, 5, 6, which means we're actually adding 5 zeros. And if we put in our commas, we end up with 2 million as our original number. So this is how we write it in standard form. Let's now take a look at number 2. 3.807 times 10 to the negative 1st times 5 times 10 to the negative 4th. So again, we're going to begin by multiplying 3.807 times 5. So 3.807 times 5 is 19.035. Then, just as we did in problem 1, because the bases of 10 are the same, we can add those exponents together, negative 1 plus negative 4, which gives us negative 5. But once again, this is not correctly written in scientific notation, so we first need to adjust the decimal and adjust the exponent. So we're going to begin by simply writing the 19.035 in scientific notation. So this would be 1.9035 times 10 to the 1st. We would then multiply that by the 10 that's already there. So again, we're going to keep the 1.9035, and we're going to add the exponent, so 1 and negative 5, which would give us negative 4. So that is now correctly written in scientific notation. We then want to move to standard form. This time our exponent is negative, which tells us in standard form the original number is between 0 and 1. So to create the number that's between 0 and 1, we want to move the decimal point to the left 4 spaces. So we would move it 1, 2, 3, 4, filling our blanks in with zeros. So in standard form, our number is 0.0001935. Now let's take a look at some additional examples. In the next two problems, we will evaluate each quotient, and we will express the results in both scientific notation and standard form once again. So let's take a look at how we might approach problem 4. Problem 4 says 3.6 times 10 to the 5th divided by 3 times 10 to the negative 3rd. So because this line indicates division, we will actually divide the numbers 3.6 and 3. And 3.6 divided by 3 equals 1.2. Now, if you recall in a previous lesson on exponents, when you were studying the properties of exponents, you learned that if these bases are the same and they're written in fraction form, so they're being divided, then what you would do is you would simply subtract the exponents. So this would actually be 5 minus negative 3. And 5 minus negative 3 is the same as 5 plus 3, which would give us 8. Now notice this is already correctly written in scientific notation because the decimal is in the correct place, so we have half of our answer. From here, we want to write that in standard form. You can see the exponent is larger than 1, is a positive, so this number, your original number, or the standard form of the number, should end up being larger than 1. So we're going to move our decimal 8 places to the right. And then fill those in with zeros. We should have 7 zeros. And then if we put in our commas, we have 1 there and 1 there, we end up with 120 million. And that would be the number written in standard form. Let's take a look at number 5. Number 5 you will do in the same way. You will divide 2.52 divided by 7.2. When you divide these numbers, you will end up with 0.35. And just like number 4, you want to subtract the exponents, which would be negative 8 minus 5. So we have 0.35 times 10 to the negative 13. Now notice this is not correctly written in scientific notation because the decimal point needs to be after the 3. So we first need to adjust that. So let's first rewrite 0.35 correctly, ignoring the 10 to the negative 13th. So if we want the decimal point to be between the 3 and the 5, it would be 3.5 times 10, and then what would happen to the exponent? It would be negative because this number right here is between 0 and 1. So it'd be a negative 1. Okay, now we're going to take that and multiply it by 10 to the negative 13. And again, we can just drop the 3.5 down and we can add the exponents of the bases. So negative 1 plus negative 13 is negative 14. So that would be scientific notation. For standard form, because our exponent is negative, we want our original number to be between 0 and 1. So we must move our decimal point 14 places to the left. The first place would be the 3, which means we need 13 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we can put the 3, 5 at the end. And that would be the number in standard form. And this completes the lesson on multiplying and dividing with standard form. With scientific notation.